All right, so I'd like to address um, the question that kind of comes up after we look at, well, if I put a +4 at the end of this, right, or a -4, then it results in a vertical shift. What if I want to shift this parabola horizontally? I mean, who wouldn't want to shift the parabola horizontally, right? Um, so I joke about it, but I think we could answer this pretty quickly, and I think with a good amount of reasoning. So we have this original equation, y equals x plus 2 times x minus 3. And lets us know that there's an x-intercept at -2, and there's an x-intercept at 3. And the second degree polynomial equation, I only have these two factors, multiplicities of 1, so I do know I have a parabola. And for various reasons, we can decide, hey, this parabola opens up. So here's a sketch of this original parabola. Not a great sketch, but a sketch. Okay, so shifting to the left 4. We'll go in orange. So that would be taking this point. Well, my pen won't change colors. So okay, so I think we got the pen issue fixed. All right, so we know there's a point at 3, 0 on the original graph. If I shift it 4 to the left, that would put it at -1, 0. And then, for all of these points, we're shifting 4 to the left. So this point at -2, 0, that would actually get shifted out here to -6, 0. Now, one way to go about this would be to say, okay, well, I've got an x-intercept at -1, so I know that x minus -1 is a factor. And I have an x-intercept at -6, and so I know that x minus -6 is also a factor. Right, just by like visually seeing this shift, and that's fine. There are some downsides. One downside is, well, what if I wanted to shift it like really, really far? And I didn't graph it. I didn't want to take the time to graph it. Or if I was just given an equation, I was asked, what's this vertical shift look like, or how does it relate to this other one? So I'd like to go through it from a different standpoint. Let's start with the equation that we have. And then we'll talk about changing that to reflect this idea of a horizontal shift to the left. So I'm going to rewrite this as y equals x minus -2 times x minus 3. Okay, so we talked about wanting to have a horizontal shift. So let's just start with our basic factors that we have, x minus, and from the -2, let's subtract 4. And again, x minus, and from the 3. Okay, so I got some things backwards, it looks like. No, I guess we're good. Sorry, we're good. So from the 3, we're going to subtract from the 3, we're going to subtract 4. So we'll simplify our expressions. We have x minus, and we have -2 minus 4, which is a -6. And x minus 3 minus 4, which is a -1. So this would simplify, or we could rewrite it, maybe not necessarily simpler, but we could rewrite it as x plus 6 times x plus 1, right, which is equivalent to this one that we kind of visually came up with. Of x plus 1 times x plus 6. So again, when we're asked about a horizontal shift, we could plot our points and then visually and actually, physically shift those points over. Or we could look at it more from an analytical standpoint and say, well, I know that I start with this x-intercept at -2, and then from that I want to subtract 4. And then I start with an x-intercept at 3, and from that I want to subtract 4. And then just work from there. So if I did that to all the points, similar to the horizontal for the vertical shift, right, if I take all of these points and shift them over 4, then my entire parabola would be shifted over 4. So I hope this helps, and remember, math is cool, and so are you.